Hello students. In this video we are going to discuss about hyperconjugation. Hyperconjugation is a general stabilizing interaction. It involves the delocalization of sigma electrons of CH bond of an alkyl group which is directly attached to an atom of unshared system or to an atom with a unshared p orbital. So let us take the case of an example, that is a methyl cation. The formula for methyl cation is CH3CH2 plus. So what this says, that is it is actually the delocalization of sigma electron. And which electron? CH sigma electron that get delocalized and that is attached to an atom with unshared system. Unshared system, or we can with an unshared p orbital. So in this case of ethyl cation CH3CH2 plus, what is the geometry shown here? As we know, that is this is sp3 hybridized carbon, and this carbon having the positive charge. So in which the positively charged carbon atom have an empty p orbital. This you can see, this have an empty p orbital. We have already learned the structure of a cation. This is a carbocation. So here this positively charged carbon have a empty p orbital. Then one of the CH bond of the methyl group, let me take this one of the bond of the methyl group, that is CH bond of the methyl group, can align in the plane of this empty orbital. That you can see, it can align in the plane of this empty p orbital, and the electron constituting this CH bond in the plane with this p orbital can be get delocalized. So there is a delocalization into the empty p orbital as it is given in the figure here. So what is actually happening here? That is one of the CH bond of that methyl group which align in the plane of this empty p orbital, and the electron constituting of the CH bond in the plane with the p orbital can be delocalized into the p orbital. So because of this reason, this interaction is called as hyperconjugation. As it is also shown by alkenes. Here also there is an interaction between the pi system. This is the pi system because there is a double bond and here single bond with the sigma electron of the nearing adjacent sigma electron. So how we define this hyperconjugation? It is the interaction between the electrons of pi systems. Pi system means the multiple bond, and the adjacent sigma bond, that is a single CH bond of the substituent group in the organic compound, is called as hyperconjugation. So in simple word we can say it is the interaction between the pi electrons of the multiple bond, that is 2 with the adjacent sigma bond electrons, with the adjacent sigma bond electrons which is actually present in the substituent group. So that interaction is called as hyperconjugation. So let us take the case of the carbocation which is shown here. The hyperconjugation, this type of overlap stabilize the carbocation because of the electron density from the adjacent sigma bond helps in dispersing the positive charge. When you can see here, this is a sigma bond, that is CH sigma bond. This is called as CH sigma bond. This I am highlighting here. So here in the case of carbocation, this is what the ethyl cation which is shown here. So here you can see that this electron, that is CH sigma electron get delocalized here. and it forms a double bond. Now you can see in the second structure there is a double bond. So this first hydrogen get removed, that is shown here. It is formed H positive, and the double bond is formed here. That is due to the sigma electrons of CH bond get delocalized. So it forms a double bond here. Similarly, when you look at the second structure, the H2, that is actually second hydrogen. Here the red line, what it is with shown the numbers, that is actually representing the particle hydrogen. So the second hydrogen get removed, and that will form a double bond here. So this is actually this type of overlapping stabilizes the carbocation. That is the carbocation, because the electron density from the adjacent sigma bond helps in dispersing the positive charge. You can see here in this images. So in general, the greater the number of alkyl groups attached to a positive charged carbon atom, greater is the hyperconjugation interaction and stabilization of the cation. So as we have already studied the stability of carbocation, that is, when we look at the stability of primary, secondary, tertiary carbocation, so we can say that the least stable one is the methyl cation, then primary, secondary and tertiary. That is, tertiary is the most stable carbocation. So that we can explain on the basis of hyperconjugation. That is, as the number of alkyl group attached to the positive charged carbon atom increases, greater is the hyperconjugation. So greater the hyperconjugation interaction, and that greater will be the stabilization of the cation. So in this case, that is in the case of tertiary, greater is the number of alkyl group attached to the positive carbon. This is the positive carbon that you can see here. This one is the positive carbon, and which is attached to 3 alkyl groups. So greater the number of alkyl group attached to the positively charged carbon atom, greater is the hyperconjugation interaction. So greater will be the stability of cation. So the stability of carbocation we have already discussed, that we can explain on the basis of this hyperconjugation. Hyperconjugation is also possible in alkenes and alkylarenes. So the delocalization of electron by hyperconjugation in the case of alkene is shown here. So in the same way, when you look at here, this sigma bond having that electron, that is CH sigma bond, the interaction between the CH sigma bond electron, and here you can see a multiple bond, that is a multiple bond is here. So the pi electrons and the sigma electrons, that interaction, it result, that interaction is called as hyperconjugation. So similarly you can see in this case, now this electron, that is sigma bond electron shifted to this side, so automatically the double bond will break, and that pi electron shifted to this carbon. That's why it develop a negative charge on this. So this is actually the delocalization of electrons by the hyperconjugation, that is in the case of alkenes. So this is about the hyperconjugation. In exams, most probably getting a question in 1 mark, that is what is hyperconjugation. So you need to explain it definition with example. So this is all about this video. Have a nice day.